Howdy, howdy, this is Mr. Potter. When I was in elementary school, I loved to draw stars. Everyone drew these stars when they were in elementary school. Some of them drew them in middle school. Some people draw them in high school. If you're a parent, you probably taught your child how to draw stars. But I was different. So, all of my friends would draw these nice stars. Everywhere, draw a star, draw stars. I would draw my stars differently. I'd draw them really tall and narrow, and then I'd come down here, and then come over here, and then come over here, and then come over here. I drew 7-pointed stars because I like to be different. And my friends are like, how do you draw 7-pointed stars? I go, well, you draw them just like you draw a 5-pointed star, except it's really tall and slender. Then when you go up here, you don't go horizontal. You actually come down here and end up going horizontal down here. Then you go up, and then you go down. So, that's the 5-pointed star. I would do the 7-pointed star. And my friends thought, oh, that's neat. Can you do 9-pointed stars? And I go, yeah, of course I can do 9-pointed stars. Let me do a 9-pointed star here. So I got a different color. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, not perfect, but I guess I could do that if I had just pen and paper instead of computer terminal. And they said, well, what about 6-pointed stars? 6-pointed stars. Let's try that. What would a 6-pointed star look like? Well, I'd go 1, 2, 3, 4, 5, 6. No. 1, 2, 3, 4, 5. No. 6-pointed stars were really hard. And what I want to do in this video is I want to explain why it's hard. So first thing we're going to do is we're going to analyze my 7-pointed stars. Keep in mind that because I'm dealing with 7-pointed stars, I really am dealing with 7 dots in a circle that need to be connected. And the way that I'm doing the connecting is I'm going ahead and I'm going across here, then I come down, then I go up, then I come back down, then I go across, then I come back up, and then I go down. What's really happening though is if I start here, the first connection that I make is 3 points away. Then the next connection I made is 3 points away. And then the next connection I made, 1, 2, 3, is 3 points away. And then I connected 3 points away, and then I connected 3 points away, and then I connect 3 points away. And this constant action of connecting 3 points, connecting 3 points, connecting 3 points is what allows me to get the 7-pointed star. Now, what I could try is I could say, okay, well, what if I were to connect different stars? So here, let me get my 7 points out here again. So what if instead of going at this starting point, instead of going 1, 2, 3 and connecting to this point, I just go 1, 2 and connect to this point. There's 1, 2, 3, 4, 5, 6, 7. And I get something that looks, well, it's definitely star-ish. It's not the same as this. It doesn't look like our traditional star. What happens if I try and do 4? So let's do that in a different color. Let's do 4 in here. So let's get my 7 points in a circle. And starting here, I go 1, 2, 3, 4. So I'm actually doing here, then 1, 2, 3, 4. So I'm going to connect to here, then 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. What do you notice about this star? Does this star look a lot like this star? That's interesting. Let's try 5 points. So again, I'm going to do my 7 dots in a circle. And from this starting point, I'm going to do 1, 2, 3, 4, 5. So I'm going to do from here to here. 1, 2, 3, 4, 5. From here to here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And of course, what I notice is that these stars certainly look equal. It certainly looks like these stars are equal. Now keep in mind, this was a 7-pointed star with 3 spaces between. This is a 7-pointed star with 4 spaces between, and they end up looking the same. And this was a 7-pointed star with 2 spaces in between. This was a 7-pointed star with 5 spaces in between, and these look the same. Interesting. Well, let's talk about what happens when I was dealing with the 6-pointed stars, because I remember we had a lot of problems. So if I'm dealing with 6-pointed stars, that means I'm going to have to connect 6 dots. And I'm going to have to connect them using lines. So obviously I'm going to have to start here. Well, what if I do 1? Well, if I do 1, then I'm connecting from here to here, then 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 here to here. That is about the most unstarry star that I've ever seen. As a matter of fact, I believe in math we called that a hexagon. So what if I do 2? So again, 6 dots in a row. If I do 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. There's a problem there. Well, these dots feel left out. Let me do that. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And this looks a lot like the Star of David. Just 2 triangles being overlapping. Interesting. What happens if I were to do 3? So again, if I'm doing 6 dots in a row, so starting here, 1, 2, 3, 1, 2, 3. And it looks like I'm overlapping at this point. Here, 1, 2, 3, 1, 2, 3. Here, 1, 2, 3, 1, 2, 3. Well, that's definitely an asterisk, which I guess is starish. What about 4? If I do 4, again, starting with these 6 dots, starting here, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And again, it looks like the same issue that I had with the 2. That's interesting that 6 with 4 spacing and 6 with 2 spacing will end up looking the same. Now you notice there's something that we forgot. We haven't talked about 5 yet, but I think you've got a hint of what's going to happen here. So here, starting 1, 2, 3, 4, 5, that's going to make this connection. 1, 2, 3, 4, 5, that's going to make this connection. 1, 2, 3, 4, 5 is going to make this connection, then this connection, then this connection, then this connection. So 6 with 5 looks the same as 6 with 1. And I notice a pattern. Really interesting stuff. So what I want to talk about next, this is a math video after all, so I want to talk about greatest common factor. This is something we learned back in elementary school, sometimes middle school. If I want to know the greatest common factor of 4 and 6, I need to know what factors 4 and 6 each have. Well, I know 4 has a factor of 1, a factor of 2, and a factor of 4. All of these are factors of 4. 6 has a 1, a 2, a 3, and a 6. And I know 1's always going to go into every number, but 2 is the biggest number that goes into both. It's the greatest because it's the biggest. It's common because it belongs to both of them. And it's a factor. So when we talk about greatest common factor, I want to know the largest number that goes into both of these numbers evenly. So if I have something like 12 and 15, and I want to know the greatest common factor of 12 and 15, I know the greatest common factor is 3, because I know both of these are multiples of 3. This is 3 times 4. This is 3 times 5. I know there's no bigger factor that goes into both of these numbers. And I know that 1 goes into it, so I know it's not the greatest factor. So we have this idea of greatest common factor, but we also have this other concept that I want to talk about, this concept of relatively prime. Relatively prime means they have no common factor other than 1. So 4 and 6 are not going to be relatively prime because they have a common factor other than 1. Similar with 12 and 15 because they have a common factor other than 1. But if I were to compare numbers like 8 and 9, well, the factors of 8 are 1, 2, 4, and 8. The factors of 9 are 1, 3, and 9. The only common factor they have are 1. So I would say 8 and 9 are relatively prime. And that's interesting. If I go back to my previous example with 6, well, 6 and 2 are not relatively prime. They have a common factor of 2. 6 and 3 are not relatively prime. They have a common factor of 3. 6 and 4 are not relatively prime. They have a common factor of 4. And what I noticed is that on all of these where they were not relatively prime, I had to pick my pen up. I had to stop drawing and start drawing somewhere else. But 5 is relatively prime to 6. And with 5 and 6, because they're relatively prime, I didn't have to pick my pen up. I was able to visit every dot without picking up my pen. Now, this wasn't a very interesting star, but I was able to complete it without picking up my pen. Going back to 7, because 7 is prime, 7's going to work with all of these numbers. 7 and 3 are relatively prime because they have no factor other than 1. Similar 7 and 4, similar 7 and 2, similar 7 and 5. You'll notice I missed some numbers here. I didn't talk about 7 and 6, and I didn't talk about 7 and 1. But that's because these are just going to give me heptagons. Heptagons. In other words, they're only going to give me 7-sided figures. So I know how to find all of the possible 7-pointed stars. I know how to find all of the possible 6-pointed stars. And I know that greatest common factor and relatively prime has something to do with it. What about 8-pointed stars? Well, let's take a look at 8. I could compare 8 with 1, or 8 with 2, or 8 with 3, or 4, or 5, or 6, or 7, or 8. Well, I can't really compare 8 with 8. That's not very interesting. Let's erase that. Bad number. And I know 8 and 2 are going to have a problem because 8 and 2 are not relatively prime. So I know I'm going to have to pick up my pen. I know 8 and 4 are not relatively prime. I know 8 and 6 are not relatively prime. That means these cannot give me stars. The only way I can get stars is by looking at these pairs that are relatively prime. 8 and 1, 8 and 3, 8 and 5, and 8 and 7. And yes, 8 and 1 are relatively prime because the greatest common factor they have is 1. So if I look at an 8-pointed star, and I start at a starting point, and I go 1, 1, 1, 1, 1, 1, 1, 1, well, I get an octagon. And I'm going to end up with an octagon here as well, because it's essentially going to traverse the octagon backwards. But interesting things happen here at 8, 3, and at 8, 5. So let's talk about what happens here. Starting at my starting point, I go 1, 2, 3, that's to here. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And so I end up with an 8-pointed star. Basically a star that I didn't have to pick my pen up to use. This is my 8,3 star. If I would do my 8,5 star, I think you'll know what should happen here. It's from here to 5, then 5, then 5, then 5, then 5, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Notice that these stars are the same. It's just a matter of traversing it backwards and forwards. So, let's talk about generalizations. If I'm dealing with a n-sided, n dots basically, I know that n with 1 is always going to give me an n-sided polygon. I saw that with 6, 1, with 7, 1, and with 8, 1. And I know that if I take n with the number before n minus 1, because we saw 6, 5, we saw 7, 6, and we saw 8, 7, this is also going to give us an n-sided polygon. And I know that n comma k will give us a star if n and k are relatively prime. Now I saw this with all the 7s. I saw that with 6, 1 and 6, 5, but those were polygons. And I saw that with 8, 3 and 8, 5. As long as k, the second number, is relatively prime to n, then I'm going to get a star, a diagram that I can draw without ever picking up my pen, visiting every single one of the points. Now, some other stuff that we looked at, if I see n and n over 2, that will make an asterisk. And of course, I can imagine if I had the 8, 4, 8, 4 is going to make these lines cross. It's going to make these lines cross. It's going to make these lines cross. And it's going to make these lines cross. I could even look at, that was 8, 4. I could even look at 4, 2. I wouldn't imagine making a 4-pointed star, because that would just look like a square. But 4 to 2 here, and 4 to 2 here. Of course, I guess that's like the worst possible asterisk you could ever have, but n and n over 2 will give us an asterisk. So here's some of the generalizations that I've come up with. And the one other thing that we noticed is that if I have n comma k, that's going to be the same as n and n minus k. This is how we notice that 7, 3 was the same as 7, 4. How we noticed that 8, 5 was the same as 8, 3. And even how we noticed that 6, 2 was the same as 6, 4. This is a pattern that we noticed as well. So this gives us some starting off points. I'd love to see what else you come up with. Why don't you write them in the description down below. Once again, this is Mr. Potter. Thank you for watching. Have a great day.